Hi students, what are we going to learn in this video? Yes, we're going to learn to find sine and cosine of obtuse angles. What we have on the screen is a circle and the x and y axis. So let's label it. Now I would like you to imagine that you are this point P that travels on the circumference of the circle. And we're going to call this, we're going to let the coordinates of this point P, X, and Y. Now, all circles will have a radius. Please remember that the radius of any circle is a positive value. And in this case here, it will be OP, and we're going to call it R. Now, we would want point P to travel in the anti-clockwise direction. So hence, this will be your first quadrant, which is between 0 degrees to 90 degrees. And then between 90 to 180, it will be called the second quadrant. And between 180 to 270 degrees, it will be the third quadrant. And finally, from 270 to 360 degree, it will be the fourth quadrant. So in today's lessons, we're just going to concentrate on the first and the second quadrant. All right. Now, so when this point P travels on the circumference of the circle, it will make an angle theta with the x-axis. And we can actually form a right angle triangle. Right. So forming a right angle triangle will allows us to use Pythagoras theorem, used Torcaso. Torcaso is, if you were to recall, it helps us to find the ratio for sine of a cube angle, the ratio for cosine of the cube angle, and the ratio for tangent when the angle is a cube. Right, so let's label all the sides first. So this will be my opposite sides. So the opposite sides is actually the y coordinates of your point P. So I'm going to put a bracket here that is your OPP. And this is your adjacent side. Your adjacent side is actually the x coordinate of the point P. So this is ADJ. And of course, the hypo. And the hypo here is the radius of this circle. So in the first quadrant is what we have learned in the lower secondary. We find the ratio for sine theta to be opposite over hypo, which is just y over r. Then for cosine theta, it's a over h, which is just x over r. And tangent theta, it's o over a, which is just y over x. So observe that all this ratio is a positive values. So angle in the first quadrant, okay, you will get a positive value. So for example, like sine 35, cos 35, tangent 35, it will give you a positive value. However, things become a bit different when the point P moves to a second quadrant. So when the point P moves to a second quadrant, so this is how it looks like. Our angle now theta is an obtuse angle. Right, it's no longer an acute angle. So are we still able to find the sine and cosine and tangent ratio an obtuse angle? the answer is yes. We are still able to do it. Right. How are we able to do it? We're able to do it using this angle, this triangle I've just drawn, and we can still use this angle called the alpha, which is the basic angle, to help us find the ratio for your obtuse angle. So how do we do it? So first of all, let's label all the sides again. So this is your adjacent side, and on the x and y in the coordinate geometry, okay, any value on the left sides of your y-axis will be a negative value, right? So that will be your negative x. The y coordinate is still positive because it's above the x-axis. And of course, the radius is still r. The radius of the circle does not change. So now let's look at how we get the ratio for sine 180, sine theta. So your sine theta, okay, will be equals to your sine alpha. But if you look at your sine alpha, the ratio is opposite over hypo. So the opposite is y, your hypo is r. Let's look at the ratio for cosine theta. So the cosine theta is equals to cosine alpha. But let's look at cosine alpha now. So your cosine alpha now is no longer a positive value. Why is no longer a positive value? Because your adjacent now, there is a negative. So it's negative x over r now. And let's look at your tangent theta. Tangent theta will be O over A. Opposite is y, but your adjacent is a negative. So if let's look at it carefully. So in the second quadrant, okay, we observe that your sine ratio is positive. However, the sine ratio for cos has become negative. The sine ratio for tangent has also become negative. What does it mean? Let's give an example. It means that sine 150 will be a positive value, but cosine 150 will give you a negative value, and tangent 150 will also give you a negative value. Right, so from this observation, okay, we can do a summary. What is a summary? It means that the ratio for sine theta will be the same value for ratio of sine 180 minus theta. Example, sine 30 will be the same value as sine 150. The ratio for cosine theta will be negative cosine 180 minus theta. What does it mean? It means that cosine 30 will be negative cosine 150. And tangent theta will be negative tangent 180 minus theta. What does it mean? It means that tangent theta, tangent 30 is equal to negative tangent 150 degrees. Okay, so that is the connections for the sine ratio, okay, in the first and the second quadrant. So how is this information going to help us in problem solving? So the next two slides, I'll give you some examples. Right, let's do a recap of what we have learned in the earlier slide. So when the angle theta is between 0 degrees and 180 degrees inclusive, so sine theta the ratio for sine theta will be the same as the ratio for sine 180 minus theta, right? The ratio for cos theta, however, will be negative the ratio for cosine 180 minus theta, tangent theta be a negative as well. So what kind of questions do you think you would face that you need to make use of these concepts? Right, possible questions would be this. Find the angle theta such that theta is between 0 degrees and 180 degrees, such that sine theta is equals to half, cosine theta equals to half, tangent theta equals to half, sine theta equals to half, or negative half, sorry. Cosine theta equals to negative half, and tangent theta equals to negative half. Right. So let's look at the positive ratio first. Sine theta equals to half. So when sine theta is equals to half, to find theta, we sine inverse it, right? And that gives us 30 degrees. Right, so we learn here that the two possible values for this angle theta to have sine ratio half. It's possible in the first quadrant, right? Which is 30 degrees. It's also possible in the second quadrant. So theta equals to 30 and also theta equals to 180 minus 30, 150. So there are two possible values for sine theta equals to half. It can be 30 degrees or 150 degrees. Okay. However, for cosine, it's a different story, right? If you were to recall, to get a positive ratio for cosine theta, it can only happen in the first quadrant. So as the result, cosine theta equals to half, there's only one possible angle, and that is 60 degrees. That's it. Okay. Similarly, for tangent theta, there's only one possible angle, which is 26.6 degrees. Okay, so how then can I make use of this? Because if you tell me that cosine theta equals to half, there's only one value, which is 60 degrees, then how do I make use of this that we have learned earlier? So I'm going to write down this ratio first. So our cosine theta is half, and our angle theta is 60. I'm just substituting in the value for cosine theta, which is half, substitute in for the angle theta, which is 30 degrees. 60 degrees, sorry. So you see that this is how we can actually make use of the connection. You see that your cosine 120 degrees will be equal to negative half. And you can do the same for your tangent. You will see that tangent 120 degrees will gives you, not tangent 120, sorry, 180 minus 26.6. So tangent, wait, let me use the calculator. So 180 minus 26.6. So tangent 153.4 degrees will gives you negative half. Okay, so now let's go on to this. What happens if your sine theta is negative half? Do you think you have an angle in the second quadrant that will gives you a negative ratio? I mean a negative value. Ratio is always positive, lah. A negative value. Yes, the answer is no, right? For this one, we won't have an obtuse angle. Right, that will give us negative half. Because the ratio for acute and obtuse for sine, right, it's always positive. Okay, but for cosine theta, yes, it's possible to have an angle, and that is what we found here to be 120. And similarly for tangent theta, we found it here to be 153.4 degrees. Another possible kind of questions would be you'll be given a triangle ABC with a extended point D, a right angle triangle. Okay, and let's have some sides. That's called the opposite sides 2, the adjacent side 3. So if you use Pythagoras theorem, that will be square root of 4 plus 9 gives you 13, square root 13. Okay, and then the question would be find part I, the ratio for sine angle ACD, the ratio for cosine angle ACD, the tangent ACB. Okay, that's it. All right, so a common mistake that most students make they actually literally go and find the angle ACB. All right, they went on to find this angle. So for sine, the ratio is opposite over hypo, so it's 2 over square root 13. And then they went on to sine inverse this value, and they get an angle with a lot of decimal place, and they use 180 minus this angle to find angle ACD with a lot of decimal place, right? And then they sine the angle, and the ratio they get will be a lot of decimal places, right? So this is an incorrect way of solving this problem. Because the sine ratio that we are going to find for angle ACD, right, would be a exact value, not one with a lot of decimal places. So this is where we need to make use of what we have learned earlier on. And that is, we learned that the ratio for sine angle ACD, okay, it's the same as the angle for sine angle ACB. Sine theta equals to sine bracket 180 minus theta. And therefore, the ratio for sine angle ACB will just be opposite over hypo, right? And if you rationalize it, 2 square root 13 over 13. Or for in elementary math, they do not expect that you need to rationalize it. So you can just leave it as 2 over square root 13. Then for your cosine, right, we learned that sine theta is negative, right? Negative for ratio of cosine angle ACB. So that will be negative adjacent, which is 3 hypos. Okay? And many people don't read question carefully. They assume that part I is find angle ACD, part 2 find angle ACD, so part 3 also no. For part 3 is to find the ratio for ACB, which is basically just this angle lah. So therefore, the ratio for tangent is opposite over hypo, right? So it's just 2 over square root. Opposite over adjacent, sorry, for tangent, TOA, T-O-A, opposite over adjacent. So it's just 2 over 3. Okay, so that's how we make use of the sine and cosine and also tangent of an obtuse angle. Okay, that's all. Happy learning.